Hi there, Alberto Savoia here. I got such great response from lesson number 1 that I'm really eager to get into lesson number 2 and get into the bit. So this is Alberto Savoia. This is the math of success specifically for product managers. I will have a series for entrepreneur and innovator at some other point, but today I'm focused specifically on product managers. So first of all, thank you for all the feedback on lesson 1. So two things that really stood out for me. People say, Alberto, I don't like math, but for you, I will make an exception, right? So I say, well, first of all, thank you. Second, that's great because you're gonna gain an unfair advantage. You know why? Because most people do not like math. A lot of product managers do not like math. That's why you will have incredible advantage over other people. Now, how do I know this? Well, because I've talked to a lot of product managers, but it wasn't until I joined Google in 2001 that I discovered a different breed of product managers. Hope nobody gets offended, but they were really nerdy product managers, right? They had books, math books in their shelves, and they really liked numbers. Remember I said what I learned at Google, say it with numbers, data beats opinion. So knowing math will give you an unfair advantage, and that's what I want to do for you. So enough for the feedback. And another comment said, Alberto, you talk about not hand waving and using numbers, but you wave your hands a lot. I can't help it. I'm Italian. This comes to me natural. I cannot stop it. It wouldn't be natural. Okay, so today we're going to go to lesson 2, numerical definition of success and failure. The question, how do you define success, is one that people usually struggle with. Well, I do not. I explain it very clearly, and you will learn how to express it just as clearly by the time we're done with this lesson. Okay, so just as a reminder, in the previous class, we learned the notation P of S, probability of success. We learned that we cannot guarantee success, we cannot guarantee failure, nor can we be very precise like predict a probability of success of 0.3756. We cannot do that. But we can have 5 buckets for probability that range from very unlikely, 10% or 0.1, all the way to likely, 0.9% or 90%. So the question is, this is how probability of success we're going to express ourselves. The question is, how do you define success? Well, very simple, right? Let's not make things complicated. That's my specialty. I make things as simple and as clear as possible so failure cannot hide. Failure hides in the nooks and crannies of fuzzy argument, and fuzzy data and fuzzy reasoning. So here's how I define success. Maybe it's better here. You have success if the actual results are greater than the expected results. And I'll explain what I mean by expected results in general. So you have a venture, you want to sell 10,000 widgets and you sell 10,001 or even 10,000, you have success. Failure I define as actual results being less than expected result. Just as simple as that. You don't need to make it more complicated. Success means that actual results, what actually happens after your product is launched in the market, meet or exceed your expectations. Failure is when your actual results fall short of the expectations. So, but that leaves the question, well, how do you express expected results? Well, how do you think I express it? I express it with numbers as precisely as possible. So remember the expression from Google, say it with numbers. So this is how we're going to say it with numbers. People familiar with my work are already very familiar with the XYZ hypothesis. It's the most powerful tool I teach. It's the best way of putting things into number, so you can use math and some of the tools I teach you in this course. So for those of you not familiar with the XYZ hypothesis, first of all, either get my book or watch one of my several videos in which I discuss the XYZ hypothesis. But until you do that, for now, let me give you a very brief introduction. The XYZ hypothesis is a way of formulating your market hypothesis in a very, very clear way using numbers. It takes the following form. At least X% of Y will do Z. Y is your target market. Z is the expected action that the action you expect them to take with your product, and X% is a percentage of what you expect the market to do. So you see, in this formula, we contain everything. We expect your minimum expected market share. That's why I write at least X%. Because if less than that, maybe you have a business, but it's not enough to be profitable. Y defines your target market, so you can define it very clearly, and Z is what you expect them to do. So let me make it easy by having an example I got in the previous video. So let's assume that my idea is this new type of whiteboard markers. Instead of going dry, when they go dry, you put them in water for 30 minutes and they're good and they can go on forever. And I've given them a name, Forever Markers. I hope it's not copyrighted. If so, please apologize. This is just an example. So here's the XYZ hypothesis for Alberto's Forever Market. At least 20% of whiteboard market buyers will buy Alberto's Forever Market for 10 times the price of regular markers by Q4 2021. So remember, so I have 20%. I think if I cannot get at least 20% of the market, is not worth it for me, cannot be profitable. Then I define my market very clearly, people who buy markers for whiteboard. Pretty simple in this case, right? And then the action, I forgot to put buy. No, of course they will buy. They will buy Alberto's Forever Marker for 10 times the price of regular markers. So notice how again, I put it into numbers. This is a number, right? It's very specified what the 20% is. And 10x, I put a price here. It's a relation to regular price of markers. And then I also put a deadline. By when? By Q4 of 2021. Right, so you see, forget kind of business plan and predictions and all of those things. This is as clear as statement as you can make about your expected target market. So let's assume, if I launch my markers, say in July 2020, and let's assume that this is market share from 0% to 100%, and let's assume that my market share is the blue dots. So it starts maybe at 1, 2%, goes 5%, 10%, 20%, and by the end of Q4 2021, I'm at 45%. Is that success? Well, you go back to the formula. Expected result was at least 20% of market share. I got 40%. Success. Clearly defined with the timeline, using numbers as clearly as possible. If on the other hand, as time passes, you look at the red dots, by Q4 of 2021, I only have, say, 12% market share, then that's how we define it a failure. Is it a complete failure? No, but we have to be precise. You gotta draw the line somewhere. So this is how I define failure and success very precisely using numbers, and we're gonna use this a lot. So now let's bring back our idea. P of S, probability of success. So now probability of success, now that we've defined success, we can express it very, very clearly as follows. Probability of success for our product is the probability that Forever Markers market share will be greater than 20% by Q4 2021. Simple enough, right? So this is a definition of success. And what we want to know before we invest, $1 million to design and launch these markers, we want to know how probable is it that they will be successful. That's what this course is all about, right? To understand the probability of success for an idea and to maximize those probability. So we know, based on these 5 buckets, right? I cannot tell you there is a 53.567% probability of success. Forget that. But I give you something that's more valuable than anything that I actually see in the market. I give you just 5 buckets, and if you can be in those 5 buckets, you will be in fantastic shape. So I can tell you that after we're done with the course, you understand the entire system, the entire methodology, you will be able to have with a high degree of confidence that the probability of success for the Forever Market markers having a market share of greater than 20% by Q4 2021 will either be 0.1, meaning very unlikely, 0.3, unlikely, 0.5, even odds, 0.7, likely, or 0.9, very likely. And I can guarantee you, this is so much more than what anybody does or teach. People try to stay away from these numbers. right? That's why I said that you will have an unfair advantage if you use these techniques, because people like to wave their hands, not literally, but metaphorically, when it comes to explaining what product success is and how to calculate the probability. I don't. And what I'm doing in this class, I'm teaching you to also not do the same. So this is lesson 2. I hope it was useful, and I can't wait to see you back for lesson 3 when things get really, really interesting. Thank you.